start recording now. All right, so let's head over to our first image that we have here on the industrial push button. And as it says, and this is what I was saying as we were kind of getting started, push buttons are the most used of all of these input devices. Almost every industrial device as machine, as it says here, I would even say all of them. I mean, honestly, I have not seen one that isn't. You know, if we're talking about industrial machinery where people are around and stuff like that, almost all industrial machines and processes have some kind of manual controlled position, even if the machine from that point forward is designed to do everything automatically. Like, for example, washing machines. You know, it's one of my go-to examples of a machine that kind of does everything on its own. You know, you set it to what you want it to do and wash and hot or cold or whatever the settings are going to be. But the machine goes through you don't have to fill the washing machine up. That used to be a thing we had to do. We had to fill a bucket and sit there and scrub, and you don't have to do that anymore. The machine does all of that. It fills the machine up with water. You know, it locks the door so you can't open it. It starts to spin. It goes one direction, the other direction. It dumps all of the water out. It does it completely automatically. However, the machine does have an industrial push button that kind of kicks things off, right? Gets things started. So now as we're getting more into the push button, we're gonna break it down a little bit better and talk about the parts to a push button. All right, and we'll talk about the parts to a push button. Because here's where it gets a little bit important. You have to be able to navigate through the parts of the push button and understand them how they are. So down here, if you want to go ahead and highlight that sentence there, where it says an industrial push button consists of a legend plate, it has an operator, and one or more contact blocks with electrical contacts on them. All right. And if you look at the image that they have there provided for you, you can see the breakdown of those three things. You have the operator, which is the red button part, and that's just the button part. You have the legend plate. This gives you some information about what the button does. Up, down, stop, emergency stop, start, all of those functions. Motor 1, motor 2, etc. And then way in the back, all right, and the contact block goes attached to the push button. And the contact block is the part of the push button that kind of designates, all right, it designates whether the push button is normally open or normally closed. All right, and we'll talk about that because backing off there a little bit. As you get into industrial machinery or industrial settings, for example, you might stare at something like this, where you have information about what the button should do. For example, sometimes, not always, but sometimes push buttons give us an idea of what they do, right? For example, if you have a green button, it's very likely that this is part of starting something. All right, if you have a red button, very likely that this is part of stopping something. So I would say, just looking at this wall of push buttons and lights too, it has some selector switches, has a bunch of stuff here, but looking at this wall of input devices, I would say, okay, that green one right up top there, that's probably turning something on, and the red one right below it there is probably turning something off. So we have an idea. We have an idea of what should be behind that push button living in the contact block. All right, if I have a green push button, I would expect normally open contacts because it is a start button. All right, I should expect normally open contacts because it is a start button. And the red ones I should expect normally closed because they're, again, used for stopping. But we don't have only those. for example, I have all of these yellow ones, right? And I have these two black push buttons here. I think that one is one as well there. I don't think they're blank holders. I think these are blanks here. Got a couple of blanks, but positions to put other buttons for this. This was, by the way, this was sent to me by a student. They worked on the loading docks, and these were for different cranes that they had to remove load and unload containers. So for example, for the yellow one, for the black button, I don't know what's behind them. I don't know whether they're normally open or normally closed. So here is something that we kind of have to now pull away from a little bit. Not 100%, because again, there are some things that I could assume, like the green one's going to have a normally open and the red one's going to have a normally closed. But the thing I kind of want to get away from is assuming that I know what type of contacts are behind the button, right? At all points from this point forward, you'll check behind the push button to see what kind of contacts are behind it. All right, so along with the highlighting of an industrial push button consists of the legend plate, an operator, and one or more contact blocks. I want you to also add these three notes here as well. Because there are some operators to get familiar with. There's only two types, so we don't have to get familiar with too many of them. But as far as manual push buttons here, or I should say industrial push buttons, which are manual push buttons, we have two types. And there's only two types. There is a momentary push button, which you guys are familiar with from your labs, your normal start and stop button. This is a this is a momentary push button. Right, we have our normally open here push button, for example, and it is momentary, meaning when you press this button and you make contact, right, and you energize the coil and the motor starts, as soon as you let this button go, it returns to the normally open position. This is a momentary push button. And if it's normally closed, same. Normally closed, momentary push button. When you press it, momentarily, here's where the word comes from, opens, and then as soon as you let it go, it returns to the normally closed position. So let's remember that also about our push buttons. A normally open push button returns to the open position. A normally closed push button returns to the closed position. Now, you can hold these forever. They're momentary as long as you're holding them, as soon as you let them go. And then we have the other type, which is the maintained style push button, right? Momentary, maintained. Maintained style push button, and I'll put the example here for that one, would be like the emergency stop or the e-stop. When you press the e-stop, that's why it is an emergency stop. The difference between the regular stop button and the emergency stop button is when you press the emergency stop button, it stays in the open position. All right, so you can quickly press the emergency stop button, machine shuts down, and if the operator, for example, is not aware that you pressed the emergency stop, and they start to try to restart the machine, the emergency stop button won't let them. All right, now, emergency stop buttons, for example, are always, and we don't have to draw L1 anymore, always drawn in the beginning of the circuit. And they don't have to be, right? They can actually go right in front of the coil. It doesn't matter. You can have one, you can have two emergency stop buttons, however many the machine is required. And then you have your regular stop button, and then you have your momentary, normally open push button, and then energizing whatever the load is. Let's just put a motor starter here. So again, you press the regular stop button, you push it, opens, and then returns to the closed position. E-stop, you push it, it opens, it stays open. You have to reset emergency stop. So momentary push buttons return to their position. Normally open returns to open, normally close returns to close. But an E-stop or a maintained push button has to be reset. All right, needs to be reset. So if you want to add that to your notes here, for momentary. All right, we want to put returns, returns to position. And then for maintained, we want to put must be reset. Must be reset. All right, that's the advantage that the emergency stop gives us. As I said, if this is open now, electricity cannot go into the circuit past the E-stop. And then if an operator is not aware that an E-stop, and it happens, all right, it happens where we put sometimes emergency stops around the machine in different locations where not everyone can see everyone. One of the reasons why you do it, in case somebody gets their hand stuck or a clothing item stuck on the machine or whatever the case may be, or something's getting jammed up and they hit that E-stop, they climb on the machine, they put their hands inside the machine, something like that. Somewhere an operator can't see this and is trying to restart the machine. Happens all the time. But the E-stop, being that it holds, and usually that's the point of it. All right, keeps things open. So you can see it here. You can see this big giant emergency stop here at the top. Probably you push that, none of these buttons below it will operate from there. All right, now you notice a key up here. They do make E-stops with a key as well, where you'll have a key that if you hit the E-stop, only the person that has the key is able to reset the E-stop. I have seen these plenty, but we don't have to get that far into E-stops. All right, now the contact block, normally open or normally close, or a combination of both. And because there can be a combination of both, here's where I say, just because we're looking at the front of a push button and it happens to be green or it happens to be red, going back over here for a second, just because that one's green, just because that one's red, doesn't mean I know what the contact blocks have. All right, and the same, I don't know what the yellow one has, I don't know what the black ones have. Maybe they're open, maybe they're closed, or maybe they're a combination of both. All right, which does happen. I'll give you an example here. I have some images for it up close. The front of this push button, if you were only looking at the front, you would see a green push button. You would assume normally open, and you would be right. There is a normally open set of contacts there, right? There's an NO normally open. But also, somebody attached a normally closed contact as well to this. Meaning, is this push button normally open or is this push button normally closed? It's both. All right, so you can't now just assume, right? Now as we're getting further into this. If it's a green button, don't just assume there's normally open contacts back there. It could be a combination of both. Now, why you would want to use this? Maybe you have a red light attached to this normally closed push button, right? And to this green one, you have the motor starter or a motor. Maybe the jog function. So every time you press that, the motor runs, the red light turns off. As soon as you let it go, red light's back on, motor's off. It doesn't really matter what the functions are, as long as you understand, again, that there can be a combination of both. And then nothing really to explore too much with the legend plate. I just have some information here so that you understand what it does. It gives you information about the device. Again, coming back to this big wall of stuff, if it wasn't for the legend plate, how do you know which crane you're moving, what machine, etc.? Which one stops motor 1 versus stops motor 3? All that information is given us in the legend plate. Now, usually, when you buy a push button, it doesn't come with the legend plate. Usually you have to buy that separately. All right, and when you go to the supply houses that provide these for us, they have some standard ones like start and stop, obviously. Up and down is another big one that they'll have a lot of. Emergency stop, they'll have those. But if you need any kind of weird, not weird, but any kind of unique thing like, sprinkler pump 1 or pump 1 or whatever the case may be, then you can have all of that made as well. But you do have to buy the legend plate separately in most cases with push buttons. In most cases with push buttons as well, you have to buy the contacts separately also. It's like buying outlets. You just buy a pack of 10 normally open contacts, a pack of 10 normally closed contacts, and then you add them to the back of the push button as needed. So usually when you buy a push button, the only thing that you get is the operator and the base where the operator is attached to. All right, so basically you get the operator, you get the ring, and this little clip that comes with it, and you get the base where that all gets attached to, and then you bring in the legend plate, etc. And the reason they sell it like that, I think it's because a lot of times this is the part that breaks or gets damaged just in normal wear and tear. Pallet jacks and forklifts and etc. riding by these, so they break them. So they sell you these just the operator by itself. So for the operator, we'll go to the next slide over. One more thing to highlight here. If you're looking at figure 6-2. The operator of this push button does not come in normally open or normally closed. All right, understand that about the operator. The operator is only the part that we do all of the action to. Right? You press, you pull, you rotate, whatever the case may be. Some operators, not all, come in different colors. Helpful green for start, red for stop. Usually it's fine. Shapes just to distinguish the e-stop versus the regular stop, for example. All right, as it says here, the operator used depends on the application. Specifically, momentary versus maintain. If I need a start-stop system, then I'm going with momentary push buttons. If I need a emergency stop system, then I'm going with a maintain. Sorry, start-stop regular, momentary, yeah, and e-stop maintained. So the legend plate, I would say, and they don't even give it its own page. Not that important, but obviously very important if you consider how would I know how to start this machine if I don't have the legend plate. The operator, also very important because this is going to give you the action that you need, the operator application, momentary versus maintain, red versus green, etc. But I would say the main thing about the push button, the most important part of the push button as an electrician is to understand normally open and normally closed contacts. Or at the very least, understand that first sentence here. The contact block is the part of the push button that is activated when the operator is pressed. So again, operators, you can buy a red push button. It's not normally open or normally closed. You can buy a green one. It's not open, it's not closed. You can buy a yellow, a black, a blue, a white, one that lights up. No matter what it is, operators do not designate open or closed. Just because it's red doesn't mean it's a normally closed push button. Everything is on the contact block. All right, contact blocks include normally open, normally closed, or as I've shown you, a combination of both. Now, the most common contact block will include normally open and normally closed contacts, like one of each. But it doesn't really matter. Right? It doesn't really matter. You can have two open, two closed, or two closed. or you can have a combination of both. But here's the other thing. Sorry, I meant to highlight this one as well. Here's the other thing that we want to understand about a push button. And that is, again, the contact blocks give the button life. So normally open contacts make the circuit. This is a new word that we want to understand. Make and break. All right, the make and break function. All right, the make and break function is the same thing as the open close function. So I have a set of notes here to help understand, all right, or put all of that together, because we have learned these words a little bit now. All right, last week when we were talking about signal, we were talking about this. So a normally open push button will make the circuit, or really what they're emphasizing there is that the normally open push button, when you press it, right, then you make contact. And a normally closed push button, when you press it, you break contact. So that's why normally open is the make function, or as the book is emphasizing it here, normally open contacts make the circuit when the push button operator is pressed, and are used mainly, not always, but mainly to start or on function. All right, and this is now how we want to memorize this. We want to memorize this in the world of normally open makes contact. When it does, it'll turn something on or energize. It is now closed circuit at that point, or start the machine, etc. But only when the normally open push button is pressed does it do all of those functions from there. And same thing with normally closed. Normally closed contacts break the circuit, as it says here, when the push button operator is pressed, and are used mainly to start or off functions. So we want to associate normally closed with breaking the circuit. We want to associate normally closed with stop. We want to associate normally closed with off. And my extra word that I want you guys to learn as well is de-energize and energize. Energize the circuit, de-energize the circuit. All right, because as I mentioned, if you have a set of coils inside of a contactor, or you have a coil inside of a relay, you're not starting this, you're not turning this on, you're not making contact anywhere, you're simply energizing or de-energizing the coil. When you energize the coil, magnetizes, and then it closes contacts but. So there's the other word again to associate with normally open and with normally closed. All right, and then it has a couple of different types here, but we don't have to go into the different types that they have. Sorry, I meant to be here. All right, we have one normally open, one normally closed. You can have one closed, one open, or two normally closed, two normally open. That's the other thing, by the way, just to show you these a little bit more close up. These contactors, all of them have, I'm not sure if you can see it that well from the image there, but there's a little hole inside the screw behind it, and that is threaded. All right, there's a threading there. What that's for is so that you can take this screw that's right in here holding that contact, you can screw it into the back of this as well, and you can build an extended contact block. So you can put another contact on top of a contact. All right, so essentially I can have 4 back here if I wanted. 2 normally open, 2 normally closed. Now that's usually as much as you can put just for room purposes and gravity, because it does start to weigh. But really nothing stops you from putting more. It would just be I don't think it functions that well as you continue to put weight behind it. But very common to see 4 of them. And this is especially when you don't have a PLC. One of the things that PLCs do is it gives you a lot of available internal contacts out of the computer. Whereas if you do not have a PLC running the machine, you need to find physical contacts. You need to put a bunch of relays on the machine's control side. You need to find ways to add normally open, normally closed contacts to the machine to do more functions with. All right, so here's where you see them a lot more. All right, now these contacts are sold, like I said, individually. They usually do come color coordinated, green for normally open, red for normally closed. And you can have one back there, you can have multiple back there. By the way, this is a selector switch, which is the next one that they're going to show us here. If you go to the next image that they have for us for the selector switch, this image is 6-5. All right, if you head over to image 6-5, you will see the selector switch. There's two types of selector switches that we have. We have the 2-position selector switch, which allows you to have 2 functions. All right, it gives you 2 positions to select from. Basically, if you look at the circuit here, what it's providing you is 2 circuits. All right, it's providing you 2 circuits. Don't worry about hand and auto. Don't worry about that right now. But look at the first contact. It's closed, heading to that manual switch, while the other one is open. So when you select to the next position, what it does is it opens the contact on the first rung, and it closes the contact on the second rung. And now the temperature switch would be the one that engages, and you would disengage the manual switch. So all it's doing, and we want to go ahead and highlight this part here. It's only one little bit of this. I mean, I'll read the rest of the paragraph, but this is the only part we want to highlight, which is a 2-position selector switch allows the operator to select one of 2 circuit conditions. Now, how many circuit conditions you can have? If we go all the way to the last sentence, it gives us all the options that are standard, right? These are our standard ones. Obviously on and off, or, you know, going up and down, left and right. It gives you the ability to manual start the machine or automatic start the machine. That's what we're seeing here on this diagram. We have a manual switch start for that heating contactor, or we can put the machine to auto and let the temperature switch do it on its own. Other functions, as I said, slow, fast, run, stop, forward, reverse, jog, run, open, close, anything. That's the 2-position selector switch, allows you to select between 2 circuit conditions. And then we have the 3-position selector switch. And what the 3-position selector switch allows you to do, here it says, and we'll go ahead and highlight this. I don't love this sentence because there isn't actually 3 circuit conditions. There is still only 2 circuit conditions, right? Let's look at the diagram so you can see what I'm saying. Right, see what I'm saying? We only still have 2 rungs, right? Here's the 2-position selector switch, 2 rungs, 3-position selector switch, only 2 rungs, meaning we still only have 2 circuits. You can still only run the machine manually, or you can run the machine automatically. That's it. But what the 3rd position allows you to do is it allows you to put the machine into the off position. One of the things that is not available in the 2 position. In this 2 position, technically you're using the manual switch for on and off, but the machine would start in some way, either manually starting or through the automatic temperature switch. Now imagine this machine is where the public can put their hands on it, so you might want to not have anyone have access to that. And then you can have the 3rd position, which allows you to put it into the off position. All right, and here again, you can select between the circuit conditions, which is all the ones we just looked at, except now you get the off as well. Manual, off, automatic. heat off cool, forward off reverse, jog off run, etc., etc., etc. All right, slow stop, which is the same as off. All right, and in the image that I showed you before, that is what this is up here. This is a key controlled selector switch. All right, there's a few of them here for this machine. All right, there's one more there as well. And I think that's one down there. Can't really tell from that one. But these allow you to not only put the machine into the off position, but it allows you to lock it into the off position or in the auto position or in the manual position. Just doesn't allow anybody to change that position. And almost in all cases, the two position doesn't have to have a second contact. It can just be the lack of one contact. But almost in all conditions with selector switches, since you have a normally open and a normally closed function, that's what we're looking at here, right? If you look at the symbol of this switch, you have one is open while one is closed. Same thing for the two position. Again, easier to even see here. The top one is closed while the bottom one is open. So that's what the back of the selector switch would look like. It would have two contacts back there. Or one. It doesn't mean you have to have two. You can just do one. If, like, let's say this was on and off, well, you don't need the normally closed kind. You just turn it to the nothing contact position, and then it would be off. All right, so those are the selector switches. There are two types, 2-position and 3-position selector switch. All right, now we're going to jump past the joystick, and we're going to head over to the limit switch. But before we get into the limit switch, let's kind of recap what we've looked at so far. So far we've looked at manual control devices. All right, for manual control devices, there is the push button, or I'll just put manual devices to shorten that up. Manual devices. All right, here we have the push button and we have the selector switch. Of the push button, again, we have our momentary style and we have the maintain style. Now, a selector switch would fall under maintain, but doesn't really matter at that point. Usually for maintain, we're focusing more on the emergency stop. Only these, all right, only these types of input devices come with these kind of contacts that, like I said, come loose and you attach them to the back of the switches. So you can put one normally open or one normally closed or both of them. You can make a green push button have a normally closed position if you want. You can have the green one have a green normally open position, which is, more common. In other words, you can do whatever you want behind these. In fact, you can forget to put any set of contacts back there and the button will do nothing. So, in other words, just to make sure we understand, we have to add the contacts to the manual devices. From this point forward, every other device that I'm going to show you now is not a manual control device, and these come with the contacts. All right, so all these switches that we're going to look at now, you have to order them in the position that you want. Again, unlike the push button and the selector switch, which you're just ordering the operator, and then you have a contact block, and then you have to put this together correctly. So I have an example of one. All right, I happen to have an example of a foot pedal switch. that was then sent to me by a student that worked with these and opened it up and then sent me it. First of all, it's very common to see this type of setup for any of the industrial switches, which is things like a gasket that protects it from the elements, water, chemicals, oil, whatever. Right, usually these are screwed into position. Here you can see an Allen set, but they're not always Allen. Sometimes they're regular Phillips or flat. Now, inside, we have our contacts. You do not buy these and add this to the switch. The switch comes with it. Some of the switches that I'm going to show you are like this one. This one is a 3-position switch. The one position here in the middle is common. Is that the common? I think that's, no, that's not the common. I can see it from there. Actually, sorry about that. Only because sometimes in the center is where they put the common, but actually this one up here is the common. And in fact, this is what clued me in. This is the 24 volts. I don't know if it's AC or DC, but these are the 24 volts going into the switch. And so the switch has the option of normally open, which is how they're using it, or normally closed. So some of the switches, and I'll point out which ones, that I'm going to show you now come like this, where you get both and you use what you want. You can use both if you want, or you don't have to. You can use one of them only and leave the other one like you see there, completely unattached. So this is a very common style for an industrial switch. And the way these works are like a 3-way switch. If you were to draw it, it would look like this with 2 outputs. It will have one normally closed, and then the other one would be normally open. And this one here is the common point. So you bring power or whatever voltage into the common point, and then if you use it as a normally closed, great. If you use it only like you're seeing here as a normally open, which is more likely that if you're only going to use one, you're using the normally open one, because then it functions like a normal switch. When I press the foot pedal here, I close the switch. I think this was for what did he say? I think it was a sewing machine or some other type of machine. I don't remember exactly now, but some kind of industrial situation where you press with your foot, you operate the machine. As soon as you let it go, it stops. Now again, you can also have, like, let's say for example, a red light attached to this, and then every time you press the foot pedal and energize the motor, it turns off the red light, and as soon as you let go of the foot pressure switch or foot pedal switch, it turns the red light back on. All right, so however you want to use the 2 contact functions is fine. Sorry, I'm starting to get the itchy throat. And then here is just a better close-up of that, where you can't really see it too well there, but there it says common. And by the way, last week we were talking about the wire reference numbers, and that's a wire reference number there, like X20. When I go over to the control panel, I should be able to find it. All right, so let's go to the first switch that we're going to talk about. Like I said, that comes the way this foot pedal switch came, where it's already built in, it has the contacts internally, and then you use it for however you want to use it. So let's head over to figure 6-9, where we see our limit switch. And a limit switch is not a manual, all right, it's not a manual control device. It is a mechanical input device, all right, it's a mechanical one. Why is it mechanical? Because, and let's make sure we highlight the first sentence there, it requires physical contact of the object with the switch actuator. All right, so it's not called an operator because there's no operator, it's called an actuator. Right? Same, only slightly different. So I have a close-up here of a limit switch. If you have your book, that you can see that one a little bit better. But this is how the limit switches come. There you can see the same situation as the foot pedal switch. We have some screws that we gotta open up that wiring block. It has a little gasket you can see there from around the side of it. Again, very typical for industrial switches to have that gasket set up. And as it says there, a limit switch is a mechanical input device that requires physical contact of some kind of object. However it is that they're using it, you can see here from this image, and you won't be able to see it too well on my screen, but it's being used down here as this, whatever machine, I can't really tell what it is, comes into contact with it, it activates the actuator. And this is one that comes in two other types of position. It comes in normally open and normally closed. All right, very standard. But it also comes with normally open held closed and normally closed held open. All right, for example. All right, I'll give you a for example when I use one of these. Let me see, do I have a page here? Here we go. So we had a machine where it would fold linen, right? It would fold like bed sheets for hotels. It would wash the bed sheets. I worked in this giant industrial laundry place. So they would wash these massive bed sheets for hotels. And of course, you know, you're not going to have somebody try to physically fold hundreds of sheets for, you know, a giant hotel room. So you have a machine. Is there actually a machine that folds it? And it's a terrible old machine, and it doesn't do a really good job at folding. I mean, it does good enough where every 20 sheets, it kind of gets stuck and the person has to stop it. All right, they would have to stop the machine. Maybe not 20, but every 100, whatever. But when a sheet would get stuck in this machine, if you didn't stop this machine quick enough, that sheet would get stuck in the rollers, and then it's going to take a little while. We had to, like, you know, break the machine down a little bit, remove some rollers to be able to take out the sheet. So what we set up was a way for the operator to open up this door handle. All right, if they would see the sheet get locked into the machine, we didn't have an e-stop. What we did was told the person to immediately open the machine. And that way they can stick their hand right into the place where the machine is, where the linen, is getting stuck. But this, of course, is a little bit dangerous because if the machine is operating, then you obviously don't want people to put their hands into the machine. But if the operator walked around, went to press the stop button, by the time they did that and stopped the machine and then tried the machine, again, the linen would get very stuck into the machine. So we designed it to where the second they opened this door, this limit switch would pop out and it would kill the machine. All right, it would stop the machine instantly. So this is a normally open, but it was being held closed. All right, when the lid or when the handle was closed, this limit switch was pushed in, so it was being held in the closed position, and as soon as you open that hatch, it would come back out and pop out into the normally open position. So that is only a function that limit switches have. It's the only switch that has this. No other switch has this function. Because this is, by the way, the only mechanical switch that we have. All right, mechanical in that form of where physical contact has to come in contact with it. So going back over to what you're looking at here, that's what I'm assuming is going on down there. What I'm assuming is going on down there is that limit switch is being held in the closed position. All right, and as soon as whatever that is lifts up off of the limit switch activates a function of some kind. All right, so I mean, it's either a normally open held closed or a normally closed held open. I don't know what it is. Again, We don't know what they are until we open them up and check them out. This limit switch comes just like the foot pedal switch that I just showed you. It will give you both options. All right, if it is normally open, held, closed, it has also the normally closed, held, open function as well. All right, just to read the rest of that. The first sentence is all you really have to highlight. It's the most important part there, but the rest is, filler and helpful as well. The physical contact is from some kind of moving object. The mechanical motion physically opens or closes a set of contacts. This we should simply associate with every function of all of these switches. Whether manual, whether mechanical like this one, or whether automatic like some of the other ones that I'll show you. The idea is simple. Whatever activates the switch is going to open and close a set of contacts. That is all it will ever do. There is nothing else to these switches. The only difference with all the switches I'm about to show you from this point forward is what activates them. In this case, physical contact of an object. Right, and from there, it's the same. It opens and closes a set of contacts. Every one of them will open and close a set of contacts. Right, there's a couple of other... Uh-oh, am I giving you the... Hopefully I'm not spreading. There's a couple of other images here. We don't really have to get too far down the rabbit hole of limit switches as long as you understand the mechanical function of it. The only other one that I like to point out would be figure 6-12. And only because if you do go into the industrial electrical world, you will absolutely see limit switches. They're used endlessly throughout all kinds of machine functions. And the reason is this here, where they have different type of actuators. All right, different ways in which the mechanical force is moved. All right, you have the lever, fork lever, the push rotor, the wobble stick. All right, those are the functions that we have. And they are interchangeable in a sense. You can, for example, you can remove this block right here. There's 4 screws on top of it. Remove that actuator and put one of the other style actuators on there. So it's very versatile. It's usually like, you can imagine a box coming into contact with this. I can count boxes with a limit switch. I can, do a lot of functions with it. I can stop a machine or anytime a box comes into contact with a limit switch, you can shut it off. These are used in elevators. Right, in older model elevators, I would say the new ones are probably working with sensors, but older model elevators had a limit switch right at the floor. So as the elevator was coming down, it would trigger the limit switch. And once that limit switch there closes or opens, whatever, I think it was closed, now the doors are going to open on the elevator. So if you ever got stuck in an elevator because it wasn't, like it went past the floor where you got stuck and then they opened the doors and you realized you were half of the floor is there, or, a little bit too high or a little bit too low, very likely what you had is the limit switch was bypassed, or it wasn't actuated correctly, or one of the annoying things about the limit switch is the fact that things come into physical contact with it. So unfortunately, over time, something coming into physical contact with it can move it a little bit. So that's what would happen to elevators. They've changed these now. They use sensors now, so sensors don't get out of position because nothing physically comes into contact with the sensor. But plenty of them still use limit switches to activate the opening and closing of the door. All right, they show you a couple more examples, so if you want to run through them on your own, that would be okay. All right, so let's jump over to the next one that'll be important for me to walk you guys through, which is the pressure switch. All right, another very used and useful switch in the industrial world. Those of you who are going to be going into the advanced courses like pneumatic and hydraulic systems, specifically pneumatic systems, which are air systems, they will use, sorry, let me center that a little better. They will use pressure switches. All right, anything that has a compressor will have a pressure switch, is what you're seeing there. That is a compressor that they have an image of right here. So, as I said, push buttons, manual activating of the operator, limit switch, mechanical operating of the, this one I would put under automatic. All right, this isn't a mechanical one. This is more of an automatic one, although, you know, we're now getting into details that aren't as important, but. Now, information up top here specifically gives us some window into the pressure switch is a control switch that detects a set amount of force and activates these electrical contacts. And as we know, when the contacts are activated, it opens or closes a set of contacts. All right, as it says down here in the paragraph. Depending on the application, normally closed or normally open contacts are used for the pressure switch, depending on the application. So here is a, because you don't really get a good image, this is a pressure switch with the cap taken off of it. All right, here's where we bring our wires through there on the side with a piece of flex, MC cable, or FMC. All right, this is, I don't remember these. I believe this one is the high pressure. Haven't worked with these in a little bit. This one is the low pressure, but I'd have to look at the box, and it'll tell you, very simple to read. But just judging by size of one versus the other, I go with that one being the high pressure and that the other one the low pressure. And this is why I say it's an automatic. Because like a thermostat, I can put it to start the air conditioner at a temperature that I want automatically. Same thing with the pressure switch. I can set this to 120 psi. I can set this to 80 psi. Pressure per square inch of area, whatever area it's filling. You know, for example, in this case is a compressor. I don't know how much area it requires to fill. This could take 2 minutes. It could take 10 minutes to fill up that whole tank. And so you set it. You say, all right, as soon as that tank reaches 120 psi, shut off. If we're using the air compressor, we're using it, it's starting to drop, 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 drop. As soon as we get below 80, kick the motor back on and start to fill the tank back up. So low pressure and a high pressure, again, this for me becomes an automatic switch. One that I can set, and then it automatically kicks on and off the motor as well. Now, just like the foot pedal switch, just like the limit switch, if you look up here, there are 1, 2, 3 sets of screws, meaning one of them is common, one of them is normally open, one of them is normally closed. All right, get that and memorize that. Anytime you see 3 possible positions on one of these industrial switches, that's what it's for. One is common, one is open, one is closed. Now, again, which one do you want to use? Whatever you want to use, doesn't matter. If you're only turning on and off the motor to the compressor, then common with normally open. All right, reaches high, close. Reaches low, reaches high, open, reaches low, close. Turns the compressor on, fills up the tank, then it opens. If you want to have a red light that shuts off every time the compressor is on, then you can use the normally closed function. A lot of times industrial buildings will have multiple compressors. When you have a pneumatic system that's running a lot of machinery, this now requires more air going into the building, so you're going to have multiple compressors. If not, you'd have one compressor never shutting off all day. So usually buildings have 2, maybe 4 compressors that you cycle throughout the day. So will you work with these if you go into an industrial setting? Yes. This is why we put the pneumatics and hydraulic classes, because it's very likely that machinery will use air systems for something. Every building I've ever worked at has had compressor lines throughout the building, which, by the way, are always leaking. They're never not leaking. It's always air leaking out of them. All right, so that's the pressure switch. They do show you a little bit more images here on the pressure function and the diaphragm, a couple of other mechanical parts about it. I'm not too concerned with the mechanical side of how a pressure switch works. All right, there you have pneumatic and hydraulic cylinders that use pressure switches, as I was mentioning. But that's a little bit extra, so we don't need to get into that side of it. All right, just so you understand, coming back over to my note that I have here, I guess consolidate a little bit. A pressure switch detects a set amount of force in PSI and activates the contacts. As always, those contacts will open or close, or both. All right, and if you guys have any questions along the way, feel free to pause me. All right, let's jump to the next one. We're going to jump a little bit ahead. 6-23 is where it takes us. There was a lot of pressure switch stuff, again, mechanical things about the pressure switch that, and pneumatic and hydraulic systems that I'm not too worried about. So the next one takes us into temperature, and there are 2 images that they have for temperature. I will just show you the ones in the books, but I will bring you to my whiteboard where I have a better image of them. Of course, since we're sensing temperature, there are 2 types of temperatures. We can sense hot, or we can set cold, or heating systems, whatever heating systems might be. In this case, I don't know what that is, some kind of heating surface or a cabinet or something like that. All right, we understand how heaters work. All right, heating systems try to maintain a set temperature. Again, this makes it automatic for me. This becomes an automatic switch. If it gets too cold or the temperature drops, your heating system is going to kick on. Same thing for your cooling system. Cooling system maintains a set temperature when it gets too warm or when the temperature rises. Now, a very obvious and common type of these is our air conditioning systems. Heating and cooling, if you have a house that also has heating. So we know of the thermostat, but let me show you a couple images of some other temperature switches. And here's the thing with temperature switches is outside of the thermostat, because the thermostat is pretty obvious, you can see it, it's on the wall, it has a number on it. Outside of the thermostat, heating switches, or I should say temperature switches, are hard to detect. These are one of those where they're not as obvious. All right, obviously a push button you can pick out from a lineup. Limit switches are clearly limit switches, you can see them. Pressure switches also, you can see them right on the top. Temperature switches, you don't see them. All right, all of them are threaded. All of them are threaded. This one is not threaded, but that one kind of goes flat on the surface. Meaning you don't see anything. There is no thing to see. So all you see is sometimes just 2 little wires sticking out, or some kind of connection point, some kind of point where we're connecting wires to. Temperature switches are one of these that are just not as visible on the machine. If you do have a temperature switch of some kind on the machine, then sometimes we have to go find them, and they're not as obvious, right? We know the thermostat, but that's not the only type of temperature switch out there. So here's my notes for the temperature switch. A temperature switch closes and opens a set of contacts based on the ambient temperature. If you have a heating system, it reacts to the temperature dropping, getting too cold. If you have a cooling system, it reacts to the temperature rising. Can't be more straightforward for a temperature switch.
Express.
Yes.
Inside those electric kettles, those ones that pull a lot of power, they have a temperature switch in there, right?
Yes, also as well, correct.
It's this weird little, the one I have, it's this weird little silver knob thing. at the very bottom of it? I'm assuming that's what it is, right?
It could possibly be it. I don't want to say yes and it not be it, but I would say something like that is what it looks like. Just a weird looking knob sort of thing, and very likely that would be it. Now, the only way we would tell, we would have to, pull up some kind of diagram on the machine and then know exactly what that is. The only other thing I wanted to point out about the temperature switch is almost always, if not always, they are open switches. You'll notice only 2 wires. We don't have common open and closed here. So they're usually just a open switch that closes when the ambient temperature requires them to. That's why I have it written this way. Switch closes, and of course, everything that closes must open. But usually that's it. And this one has 2 wires here as well. You can't really see it too well from the image, but it has 2 wires. This one has only 2 places to put the wires. This one here, I don't know what I think it might be mechanical, but this one has only 2 wires as well. So this is the type of switch where, as I said, I would point it out when it is like this, that does not have the 3 options for it. Usually it's one of the other versions that have the 3 options for it, because this predominantly is a open switch that closes. Not that you can't buy a normally closed, but it's just more likely that they're like that. And they don't have too much else on your temperature switches here. They only have these 2 images, one for the heating, one for the cooling. Cooling, we know. Cooling systems are pretty obvious. All right, let's jump into the next one, the flow switch. The flow. Now, this one is used everywhere. All right, 6-25. For those of you who did Code D with me, and we talked about fire alarm systems, and I mentioned sprinkler systems, and I said that flow switches were part of sprinkler systems, and you can see it right here. All right, then I'd say, hey, when you get to motors, you'll talk about this switch again. Here we are. A flow switch is and this is what we want to highlight, a control switch that detects the movement of some kind of liquid. What kind of liquid? Any kind of liquid. I mean, food processing systems, olive oil, whatever, soda, juice, Gatorade, all of that. That's going to sense flow. Sprinklers, obviously, for our fire suppression systems. Water treatment plants, refrigeration, chemical processing. Your gas stations, fluid pumps. All right, even compressors and boilers and all these other machines will use flow switches. All right, again, one of the most popular ones is, if you look at the next image, is the sprinkler system. It says here, a normally open electrical set of contacts can be used to tell the fire alarm, hey, a sprinkler has gone off. And again, as I was mentioning for the Code D folks, which I'll mention here now, the sprinkler system, when a sprinkler goes off, all that's going to happen is water starts to move in the pipes of the sprinkler system. And when the flow switch senses movement of water, that's what it tells the fire alarm system. Water is moving somewhere. I don't know where, but you got a fire somewhere. Now, this one says both normally open and normally closed contacts can be used with the flow switch. I have a flow switch here. Here again, it only has 2 wires, meaning you either buy a normally closed flow switch or you buy a normally open one. Now, because they're used in fire alarm systems and a lot of times the function of normally closed is also very useful. Unlike the temperature switch where I said it's usually an open switch that's closing to start some kind of heating or cooling system. With the flow switch is a little bit different because it actually is a good idea now to use a closed switch, and they have a little weird flag looking thing like that. That is just always sending a signal to the fire alarm panel. As long as the switch is closed, the fire alarm panel is receiving a signal from the switch, and as long as it receives a signal, everything is good. The second this switch were to open, and now the fire alarm panel is not receiving that signal anymore, we got a fire somewhere. Or, one of my sprinklers has gone off. So it is very common in the world of flow switches to use a closed switch for some applications. All right, because most of the time, the flowing of the liquid is good. Flowing of liquid, as far as machines that are filling something or gas tanks that are filling something, if liquid is flowing, everything is good. In the event of a fire alarm system, it is bad when liquid is flowing. So it's very common to see them in both. But as I said, you can see they're used in a lot of industries. And as I said, flow switches can either sense that there's something there, presence, or sense that there is not something there. All right, for example, it's not sensing any water going through the pipe. Well, then we got an emergency here because water should be going through the pipe. Or food processing system, we're out of Gatorade. Oh no, everybody panic. It's giving you here, for example, is an automatic sprinkler system used as a fire protection. The flow of water indicates a problem. In this application, a normally closed contacts on the flow switch would be used to sound the alarm. So yeah, also you can have an open one that when water is flowing, it closes and then it sends a signal and goes, hey, we got problems. Both applications are fine. All right, they got a few examples of flow switches here. In this one, it's airflow that they're sensing. To be honest, I haven't worked with an airflow flow switch. I've only ever seen them for liquid. This would be something more in the heating and refrigeration side of things. I'm not too familiar with it. I can understand how it's working. There, if you look at it here, there is a little paddle that will move. If you have pressurized fan or heat or some kind of, it can move that paddle. I've just never worked with one or seen one like that. They have a couple here that they're showing us. Like for vapor and airflow, I've never worked with an airflow one of these. Plenty of liquid ones, water treatment and pumps and all kinds of stuff. So yeah, I'm not too familiar. I'm more familiar with the ones that are over here, right? For something like that, like this image that they have here. This is for a water pump. So you have a flow switch and senses, all right, water's coming in or water's leaving. Just been more. And this is what they look like. Again, this is one of those where it does go threaded into the machine. It is a little bit more obvious with a flow switch. Sometimes, like especially for a fire alarm system, it'll have a red box over it so you can clearly identify it. All right, and last but not least is our liquid level switch. There is one more, but this is the last one that the book is showing us here. And a liquid level switch, or sometimes called a float. All right, a float, if you go to image 6-30. All right, 6-30, you'll see here it uses a float that moves up and down. This is why in the industry we call this a float switch. All right, I've never heard anyone call it a level switch, or certainly not mechanical level switch. No one's talking like that. So for short, we usually just call this a float, F-L-O-A-T. Now again, I've just talked about a flow, so float could be a little confusing, but float or level switch is same. Mechanical level switches are used where first lever switches are used, and still one of the most common. Now there's two types of these. This is why I have two images here. I'll come over to them here in a second. There's a mechanical one, and there's an electric one. All right, here you'll notice there is no normally open, normally closed. We're not talking about open and closed. Mechanical level switches may be used with different liquids. So, for example, this one here, the one on the left. Right, you'll have, let's say, water coming into the tank. Water's coming into the tank. Tank's starting to get full. Tank's starting to get full. Tank is starting to get full. By the time it's full, that little ball right there is sitting up here. This lever is up, and the water is shut off mechanically. As the water is used, or whatever liquid is used, and used, and then this little ball starts to drop and drop and drop. Once it gets all the way to the bottom, liquid starts to come back into the tank, and it never is empty, right? Your tank is always able to maintain liquid. They have those, but those aren't always good for every application because size of tanks. Right? You would need a massive system like that inside, and a lot of times with water pressurizing or any kind of liquid that's a little bit denser or heavier, it's not going to move this little ball up and down as much. This is like what our toilets used, or maybe like a small little sump pump or a water pump that's little. But if you have a massive tank, then usually they drop one of these. All right, they drop that float switch all the way in. There's a wire that goes all the way to the top of it and just sits on the bottom of this tank. By the way, your car has something a little bit like that as well for your fuel tank. So with the float that's electrical is different. As it comes up, as it comes down, it opens and closes the contacts. And here on this one, you'll notice 1, 2, 3 wires, meaning you have common, normally open, normally closed for that one. So I have a set of notes here. I don't think the book gave us a great set of notes for this one. It's in there somewhere, but yeah, here's my notes, and I don't really see it too well. I think I just, yeah, it's the second one there. Mechanical level switch is a level switch that uses a float that moves up and down with the level of the liquid and activates electrical contacts at a set height. So these are electrically moved or mechanically moved. Now, the reason I was saying this is the last one is because this is the last one the book talks about. All right, that's it. It wraps it up right there. However, there is one last one that I want to just mention, which is sensors. All right, sensors have replaced a lot of these switches that we've talked about today, especially the limit switch, float, the level as well. You put one sensor on the top, one sensor on the bottom of the tank, tells you when it's full, tells you when it's empty. All right, a lot of these have been replaced with sensors that are just a lot better. All right, and they can do a lot of things: mechanical, magnetic, thermal, optical, and speed. One of the biggest advantages with sensors is speed. They can count very, very high speed things going past the front of the sensor. Whereas, let's say, for example, a limit switch, no pun intended, is limited at how many boxes can I get through there? One box. How fast is this little lever going to come back up? Where my next box, if I run the boxes too fast, then the level switch or the limit switch never pops forward. So I can't accurately count boxes. It just seems like one box passed by. Whereas with a sensor, I can send boxes, 100 boxes per second in front of that sensor, and it will count every one of them. So there's where the biggest advantage has changed the game a little bit. This is why the computer PLC was needed, because you can't do this without a computer. You can't have 1,000 things pass in front of a sensor and the sensor not be, you can't have that sensor trying to activate relays 100 times per second. It's just not going to physically do it. It'll burn this out. Same thing with our motor starters. Can't do it. Can't have 100 times per second hit that coil. It'll burn it out. So here's where the PLCs took advantage. So just want to mention that as you go into PLC Next modules, we'll talk about a lot of sensors. They've replaced a lot of the functional things that we work with today. But at the end of the day, I would say, if you understood, coming back over to this, if you understood the operators, momentary, maintain, excuse me, the mechanical versus automatic versus manual, you understand that the contact blocks give life to the switch. Either it's open, closed, or a combination of both. Legend plate, I would say know it, but it's not as important. Then you got a good grasp on these control devices.